Bird brains are tiny. The common pigeon's is about the size of a peanut. But having smaller noggins doesn't mean birds are unintelligent. One way scientists estimate brain power is through the number of neurons present. Some birds have upwards of 1 to 2 billion, similar to monkeys. The intelligence of birds, from New Zealand parrots that understand probability to ravens that can plan for the future, isn't a surprise to researchers who have long seen their capabilities. Early models proposed that only a small region of bird brains was responsible for complex behaviors, but this has been revised in recent years. Still, the detailed internal organization of bird brains hadn't been explored until now. 2 new studies in Science dig into their structure and function, revealing even greater similarities to mammalian brains. Researchers shine different angles of light into extremely thin slices of the pallium, the area of the bird brain with a similar function to the neocortex of mammals. This allowed them to see a 3D view of the fibers that connect neurons. The fibers of owls and pigeons were organized much like those of mammals. Parallel fibers along the pallium were crosscut by perpendicular fibers between layers, forming columns of connection. These microcircuits could explain how birds are capable of complex behaviors, like newly discovered conscious experiences. Researchers tested whether crows are aware of what they see and do. First, they trained 2 crows to indicate whether they saw a faint light, a dark gray dot on a black background. After they flashed the dot and showed the rule for that round, which varied to prevent the birds from preparing their responses, they asked the crows to report what they saw. Because the dot was hard to make out from the background, the crows sometimes failed to report accurately. Instead, they had to decide whether they perceived a dot or not. Researchers inserted electrodes into the crows' brains to monitor how hundreds of neurons responded during this exercise. When the crows indicated that they saw a stimulus, hundreds of neurons fired before they made their selection. Those same neurons were silent when the birds demonstrated that they didn't see the faint dot. This response shows that the activity of birds represents more than what they see, adding them to the animals capable of conscious thought. Although the most recent common ancestor of birds and mammals was alive about 320 million years ago, both these studies show striking similarities between their brain capabilities. Bird brain may soon become an insult of the past.